Okay, everybody, question 15. The path of a basketball shot can be modeled by the equation h equals negative 0.9 d squared plus 0.9 d plus 2. Now recognize that it's quadratic. Okay, that's our first step. Now, where h is the height of a basketball in meters, notice this negative 2. Remember, the first time is to factor it, so we know it's going to be some kind of a parabola. And if you look, this kind of the path of a basketball shot, it shot up, it hits here at a max, and then starts to fall. Where h is the height of the basketball, h, that's our y value, and in meters, and d is the horizontal distance. That's kind of like our x value. So anyway, what is the maximum height reached by the ball? Well, if we draw, it's going to be right there. It'll be our y value. And what is the horizontal distance of the ball? The horizontal distance would be, basically it's asking us for the vertex. It'd be our xy value of our vertex. How far from the floor is the ball when the player releases it? So that's the initial value. So when the player releases it, that would be at time equals 0, or distance from the player. So it'd be right here. Wait, where does it start? Where does it cross? Where does it cross the y-axis? That's basically what C is asking. So let's write out our equation. H equals negative 0.09 d squared plus 0.9 d plus 2. First step, take out the common factor, or take out this. Factor out 0.9. I know it's not a common, but we can still factor it out. Negative 0.09. We're left with d squared. Now, we got to take out 0.09 from that. How do we do that? 0.09. Whoops. We take our value here, and we divide it by negative 0.09. What do we end up getting? We can multiply the top and bottom by 100 over 100. So that gives me 90, right? And this will give me negative 9, which is equal to negative 10. So I say negative 10d. Okay, what else? Well, we got to add and subtract something to it. Let's just leave some space here. Just add this plus 2 out there. Okay, what are we going to add and subtract to make this a perfect square? What does this have to be? Well, we take this b value, this second value, minus 10, divide by 2, and square it. That's going to be c. C equals negative 5 squared. C equals 25. So we add 25 and subtract 25. Okay, now we have a perfect square here. That's basically d minus 5 squared, right? But we also, let's write it out a different way. H is equal to negative 0.09 d squared minus 10d plus 25 minus 25 times 0.09. Oh, is that a negative? Yes, negative. Basically that times that to bring it out of the brackets, plus 2. What do we end up getting? H equals, this is a perfect square, d minus 5 squared. And then, what's minus 25? Basically it becomes a plus. And how do we do that? 25 times 0.09. 25 times 0.09. 0.09. 2.25. So let's solve that. Plus 2.25 plus 2. So h becomes negative 0.09. D minus 5 squared plus 4.25. So what's our vertex? Our vertex is 5, 4.25. And it's upside down. So our vertex is going to appear. Let's move all this. Our vertex is going to be somewhere here. 5. Oops. 4.25. And it's going to, that is going to be the maximum height of the ball. I'm not sure where it's going to go, but I know it's going to be the maximum height of the ball. Okay, so I'm not going to draw it yet, but I know the maximum height is 4.25. And it happens, if this is where the ball starts somewhere, it's going to go in this direction, 5, and the maximum height it's going to get to before it starts to fall is going to be 4.25. So A, max height is 4.25. B, the ball is 5 meters away from the shooter when it reaches the max. And now finally C, it's saying how far from the floor? How far from the floor is the ball when the player releases it? How are we going to find this value? I drew it here, but that's not really true. I drew it, where is it? Is it here? Is it here? Is it here? Well, it should be positive for the question to make sense. But let's try solving that. Let's try solving that. And basically, when D, the answer is, what is H when D equals 0, right? Distance from my player is 0, so it's still at my player. So let's substitute it. In fact, we can put in the original equation. H equals minus 0.09 D squared plus 0.9 D plus 2. Guess what? If D equals 0, that doesn't matter. That doesn't matter. H equals 2. So guess what? The ball is 2 meters off the ground when it is shot. So basically, my parabola is going to look something like this. Right? And it's basically a very compressed parabola. And that's my answer, A, B, and C.